So we're at Skyfiber here in Plano, Texas, a startup of sorts.
Right.
You're the co-founder.
That's correct.
Chief Technology Officer. We have Wally here. We're going to talk about Wally in a second. But first, tell us about Skyfiber. I can extrapolate from the name that it has something to do with sending a lot of data through the air pretty fast.
That's correct. Years ago, I was doing research on my 14.4 kilobit, phone modem, and banging my head on the monitor, wishing that it could go faster. At the time, I was researching some of our now competitors' products, which literally were the size of small refrigerators with massive satellite-type dishes on them, and we're in the $100,000 plus range. And I became really enamored with the technology and thought to myself, hey, what if, it's one of those what if moments, and what if we could take this cool technology and reduce the size and the scale of it and start building citywide networks to be able to get broadband to the home, because I realized in my home I would never get fiber to the location just simply because of the expense and the time and the right-of-way issues that it would take to make that happen. It took us a long time to have some breakthroughs in the technology, from just hands-on field experimentation and things that we actually thought the whole industry understood, that years later we found out that they didn't understand it. And so that's one of the reasons why our technology has actually garnered success in the market with particular customer in Mexico, because he'd tried the technology before with some of our first to market players and our competitors. And he said, I tried it, and didn't do what they said they would do. He says, I like the technology, I like the concept, but you got to prove to me that it works. And so we did that back in 2008, actually, late 2008, and over a 6-month trial and test there for a company in Mexico, we were able to successfully prove to him that the technology did indeed work as we had built it.
So, Christina, set the market stage for us, right? We all know the history of the fiber build out in the 90s and early 2000s, and poof, it all sort of came to a grinding, ugly halt. And now we're starting to come back up that build out scale.
Yeah, we really are, and there's just such a great need for bandwidth right now. I mean, we've all got at least one smartphone in our lives, probably more devices than that, and it just drives so much data need from those devices. So you've got all these networks that are really overloaded that need additional capacity. And just to let you know a little bit about what this unit does, so basically this little guy sends out an invisible beam of light, so an infrared beam of light. It transmits it over to another unit just like this one, and it sends 1 gig of data across that 1 mile distance. So just to give you an idea what 1 gig is, that's 1,000 megabits. So if you have, say, 10 megabits, 20 megabits coming into your home, and compare that to 100 times that, that's the kind of bandwidth we're talking about here. And that's from this little unit right here, and that's just one. You can put multiple ones together as well.
What about atmospheric situations, fog, rain, snow, that kind of stuff?
Well, that's a great one. For example, today you can just barely see the building that's out through the window here that looks like a pyramid with 2 squares on the top of it, right?
Yep.
So we have a link that actually goes out to that across Interstate 75, and that link is operational today. So it can handle medium to light to medium fogs. If you had a pea soup fog where you literally couldn't see across the street, that would be an issue. And typically, our customers use a backup path that's lower speed, or a T1 line, or Ethernet line, or even a backup radio, RF radio, to account for those type of extreme events. But as you can see, we've had quite a good fog today, and the link's up and operational.
So what was let's talk about this one in particular. What was your biggest engineering challenge in this?
Oh, well, there were a lot. Sometimes you feel like you're going to create a project that's the equivalent sophistication of a small airplane. And as you get into it, you realize you're not building an airplane at all, you're building the space shuttle.
Right.
And that's the task from my standpoint of taking something that used to be the size of a small refrigerator and compacting and putting it down in a very cost and economical way. And that's really where one of the things that Avnet has helped us do is to come in, especially on electronic circuitry, as you can look and see the electronic package. You know, it's not simple, and it takes a lot of effort, a lot of skill set, and the right parts and pieces to be able to go into to make a product like this economical. And so through our relationship with Avnet, they've been able to not only bring us as a distributor the right access to the right vendors, but also along the way they've been able to bring us technical help where I think we've even they brought some programmers to us in some points where we were struggling with issues around the programming of one of the chips. And so that relationship has been significant in helping us to be able to build this particular product. But so that's on the electronic side. But obviously, when you're shooting a laser beam a mile, the steering mechanism and the repeatability of how accurate these devices have to be is an extraordinary feat. And I think it was one at first we thought, oh yeah, we can do this, no problem. And then once you get into realizing actually doing it, it's another thing to get all together. I'll give you an example. So your transmit and receive lens, okay? In these two lenses, that if you don't have these two lenses looking down range at the same, let's say you have one lens that's just slightly misaligned.
Right.
Well, the product doesn't work, okay? And so one of the things that we had to develop was in-house capability to be able to line these two cells within 1/20th the width of your hair. Okay, and then to be able to put that out onto the field and through the temperature cycling to be able to maintain that significant engineering challenge.